logical reasoning is probably something that most of us do not study in our school. In fact, no university also offers a course on logical reasoning. That makes it pretty intriguing, and the best thing is most of the competitive exams, be it for MBA, be it for study abroad, or even at the undergraduate level entrance examination, map logical reasoning. The biggest worry about logical reasoning is that we don't practice. We don't know exactly what is logical reasoning. We are not acquainted with the type of questions that may come. In fact, there is no syllabus for logical reasoning. So having said that, today the aim is not to just find out what logical reasoning can do. We are also trying to understand how to be better in logical reasoning. So over the course of the next few sessions, the idea is that all of us become better. Question is that, is logical reasoning easy? Of course not. If you look at CAT last year, most of the students generally with a technical background, right, with a tech background, guys with a tech background, I'm sure a lot of you have a tech background, right? Most of the students with a tech background used to find verbal section or the English section difficult, right? Even they did reasonably good in the English section. It was their Achilles heel, but even they ended up doing good. Many of the other students, right, who did not have a tech background ended up doing the math section or the quant section better, as the section was easy. So what was the Achilles heel, or what is the problem in the entire paper of CAT was logical reasoning. I personally know many students who wrote CAT 2017 who scored a 99 plus percentile, but in logical reasoning their score was down, only about 50 percentile or 60 percentile, but not even a 80 percentile. Even in fact, CAT was okay with the 80 percentile to take people on, right? So the problem with logical reasoning, why is there so much of a problem, is because most people do not work on a structured approach. Structured approach, right? What is a structured approach? That is exactly what we are trying to do in these classes. I'm guessing you guys are okay with me. If you guys are okay with me, probably you guys should post a thumbs up or something so that we are on page. We look at a structured approach, and the structured approach will not happen in a day. Unlike math, when you're learning math, every time you learn a question, you look at the curve that I've drawn, you look at the question, right? Your learning curve will be this way. This is the math learning curve. This is the math learning curve. But LR, the learning curve is going to be like this, and then one fine day there will be a point of inflection right here. So this exactly we are going to take some classes to reach here, and from here we will rise. We'll have a drastic rise, and count on me, right? As long as you guys are with me for the next few classes, right? No one can stop you to score above 99 percentile in LRDI section. As long as you just follow some of the things that we are trying to do and try to extend the logic in whatever simple way that you can, right? So I think we are good to start with today's session on logical reasoning. You will find that in today's sheet, few of the questions are at CAT level. One or two questions may be a little lower than CAT, because CAT also has some easy questions. But then sooner or later, you will see that you are taking it to a level way higher than CAT, and that's exactly what you want to do. Probably you want to reach a level where you are doing really good or really good in LR. DI, I am sure most of you will not have a problem, but still we have taken some logical caselets in DI, right? Just in case they come in CAT, and even last time you would have seen a lot of questions in, in CAT 2017, right? They were logical caselets or LR based DI. So we'll look at that. We will look at that as the sheet progresses. Let's start off with the class. Without any further ado, let's start with the class. That's more important. Let's work on logical reasoning. By the way, have you ever wondered what is the meaning of logical reasoning? Right? What is the meaning of logic and what is the meaning of reasoning? Probably in the course of the class, when we do a few questions, we'll figure out the meaning of the word as well. Right? So let's start with the first question. First set of questions that you will have. Most of you can see the questions. I call it the question 0. This is dedicated to India's invention or India's contribution to the entire world and the start of the decimal system. So that's why the question 0, right? So let's start with the question. By the way, it's a series based question, pretty simple. Probably some of you can look up and take probably a minute's time and look up this series and figure out how you might do it, right? Let's take 10 seconds time. Okay, so that's about 10 seconds time. Most of you, I'm saying most of you, in fact, when I looked at this question for the first time, the logic would have been the first number is 1, next number is 11, next number is 21. So most of the people look at the difference here, the difference being 10 and the difference being 10, and they start thinking if the difference is 10, it should have been 31. So probably they've split the number 31 and written in the format 1 to 1 1. Of course, that logic does not hold any ground in this question. This question may be slightly different, right? Though this is a number series question, it has a good element of logic involved. Are you guys with me on this, right? I hope you guys are understanding what we are trying to do. With this question, we'll try to build not only the logical reasoning, but also a mindset of how to start thinking laterally and cognitively. Right, let's look at this first number. The first number or the digit here. So we have 10 digits in our decimal system, right? Our system is formed out of these 10 digits. 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Right? These are the 10 digits that we have in the decimal system. Right? So when we are talking of these 10 digits, right, every number that you and I can possibly perceive is based on these 10 digits. So look at this. This is a digit. The first thing is a digit and the digit is 1. The question is how many times is the digit there? The digit is primarily there once. So we have once the digit 1. Are we okay? Are you guys with me? When you look at the second step, I've just rewritten this statement in English in terms of digits. Once we have the digit 1. Are you guys with me? Right? We have the digit. We have once the digit 1. We have once, this is once we have the digit 1. But you look here, how many times is the digit 1 there? That is twice. So that's what I've written here. Twice we have the digit 1. Twice, 2 times. Once and twice. Twice we have the digit 1. But here something unique happens. Here something unique happens. Okay, let me rewrite that. Right, you must have noticed by now there's a lot of clutter on the on the projection. But let me rewrite that. And you'll notice here we had once the digit 1, while here we had written the same thing. Okay, now we have twice the digit 1 that we wrote it here. 2 times the digit 1, while here we have once the digit 2 and once the digit 1. That's exactly what we're going to write next. Once or one time we have the digit 2 and one time we have the digit 1, or once we have the digit 1. But technically thinking, the next step should have been thrice the digit 1 and once the digit 2. However, you look at the next step, it's given 1, 1, 1, 2 and 2, 1. So if you look at it, what we have done is we have taken this, once the digit 1 that I've written here, the next part, that is the digit 2, once we have the digit 2, and the third part, we have, the digit 1 but 2 times the digit 1. That's exactly what we have written. Once the digit 1, once the digit 2 and twice the digit 1. And that logic will work, and you'll notice it works wonders. And once you know this, once you know a pattern like this, you can start thinking on questions even if it is slightly different. I'm not saying it has to be the same question, and logic is exactly about that. Once you know one type of pattern, you can start building on the pattern. And in today's session, you'll notice that there are questions of this type, and I'm sure this will get you to think, why was logical reasoning probably not dealt in a way like this? And that's what I want to make sure that you guys start thinking in this process. Once we are in this process, you'll see logical reasoning can become much more simplified than the regular method of writing 1,000 caselets and just going to the exam and solving and still not yielding results. right? So I hope you guys are okay with the fact with this question. So if you notice, right, we have here, the question was what is the answer. So we have the digit 3, we have once the digit 3, and then we have once the digit 1, we have twice the digit 2, and again we have twice the digit 1. And probably you can take another step, right? Probably we can write another step just to help you get acquainted further with this question. Here we have once the digit 1 here, then we have once the digit 3, we have twice the digit 1, we have thrice the digit 2, and once the digit 1, and so on and so forth, whatever the logic, right, that will hold ground from here, right? Pretty simple. So the answer here will be once the digit 3, once the digit 1, twice the digit 2, and twice the digit 1. That's our answer. And you notice that this question is simple, it looks very simple, and probably to think of it, most of the good students, right, may not be able to figure out the answer that quickly, and you should get into a process where you're able to do that much quicker. And in series is normally, the series has come in CAT before, but now series is common in exams like the NMAT, right? If you're able to solve series question quickly, trust me, it builds your thinking, right? And I would recommend many of you to look at little complicated series one. Normally when I am talking of a series question, I would divide a series, a number series or a alphabet based series question into these 4 categories. 1, the question can be solved using addition or subtraction. 2nd, the question can be solved using multiplication or division. 3rd, the question can be solved using power or factorial. Now factorial is an offshoot of multiplication, we understand, right? Power, factorial, and we have something called a special series, right? So we can broadly categorize. Now some of the questions you might say, hey listen, there is a square plus 1, so you can mix and match. We can mix and match a lot of things. Now this question that we did, that the question 1 was a special series. It has no connection with your regular series. It is not that if you know addition better or if you know subtraction better or you know factorial better, you will be able to get the first caselet right. So let me do one thing, right, without talking only about the first question, right? I would request you guys to look at the second question and take a look at the second question. Again, like I said, I will give you about 10 seconds to look up this question, right? So you have your 10 seconds. Okay, so that's your 10 seconds, right? So I think we should start with the question. The question. So what I have noticed, and a little bit of my experience in this field tells me most of the students think of this question this way. Okay, I'm first going to discuss the way which most students think, and then we're going to discuss about the question, right? So most of the students think of it this way. The question 8 into 2, that's equal to 16. 16 minus 1, that's equal to 15. So we got 15 here. While if you check 15 into 2, that's equal to 30. 30 minus 2 is equal to 28, and we got the number here. And we have 28 into 2, that's equal to 56. 56 minus 3, that's equal to 53. We get the number here. So but obvious, by the same logic, we should be getting 53 into 2, that's equal to 106 minus 4. So you'll notice here there is a minus 1, minus 2, minus 3, minus 4. That should have given us a 102. Well, this logic is good. This logic is pretty good. I'm not saying any problem with the logic. In fact, this itself could have been a question, but there's an issue here. There's a pertinent issue. There's a issue that we have overlooked, and the CAT test maker want you to actually think of the question's answer this way. But the issue is the first digit, which is 1. First digit, which is 1, and that's where the catch is. That's where the catch is. You're ignoring 1. I cannot say 1 into 2 minus 0 is equal to, right, some number like 8. We're not fetching this result, right, which means there is an issue. So the question has to be dealt in total. In fact, in any number series, if you cannot take all the numbers in the series, right, every number in a number series, every number has to be part of the series. and I mean every number. Please understand, every number. You cannot skip a number here and there, right? What will happen is then we are taking a chance. We're taking a second guess and a second fiddle, like we do most of the times in reading comprehension. Now maybe this is the answer. No, that does not work in LR, right? You have to take you cannot just take a guesswork, right? We can take multiple cases. We never do guesswork in LR. Guesswork may even work in quant sometimes, but not in LR. Let's look at this question. This is a simple question, right? You will find questions like this pretty much on the internet. It works on the multiple subtraction rule. It's also called the chain rule of subtraction. So let me just explain this to you with this example, right? If you take the difference here, that happens to be 7. What I mean to say is 8 minus 1 is 7. Again, we take the difference. 15 minus 8 is 7. We take the difference. 28 minus 15, that is 13. We take the difference. 53 minus 28, that's equal to 25. Now notice these four numbers. It's not forming a series. However, if we take the second, that means the chain level, again and again we take the difference. We take the second step of difference. We get 7 minus 7, that is 0. 13 minus 7, that is 6. And 25 minus 13, that is 12. And voila, we have got a series here. We have 0, 6, 12. You see there's an incremental value of 6 every time, right? So 0 plus 6, 6. 6 plus 6, 12. 12 plus 6, that is 18. And 18 plus 6, that would be 24, and so on. But you know what? We want to get back this number, right? So you noticed 1 plus 7 became 8. 8 plus 7 became 15. 15 plus 13 became 28. Same way, we have 7 plus 0, which is 7. This 7 plus 6 is equal to 13. This 13 plus 12 is equal to 25. So we're going to add this 18 and bring up one number here. So 25 plus 18, which is 43. That means this number 43 will be added to 53. 53 plus 43, that is 96. And just in case you guys want to get a little better on this question, let's try another step. So here it will be, we're going to add 24 to this number. So 43 plus 24, that happens to be 67. Most of you would have done that by now. I'm assuming you guys have your pen and paper, right? Please give a yes if you're having a pen and paper and trying to solve the questions with me. That will be a big boost to me, right? We are all working together on a platform that's called the ANC Classes, and we are doing good. And trust me on this, we're trying to transform the way you're going to work with LR from here. We're going to transform it. You just have to be with me. There are these about 8 or 10 sessions, and you'll see the change, right? And you'll let me know after a few days. The change will be so significant that these type of questions, this would be just a minuscule problem. Even tougher questions, and I'm not talking of CAT level, I'm talking of a level higher than CAT, will be much more simpler, because you'll be thinking logically on a logical reasoning caselet and not just thinking. So I hope you guys are with me, and I hope you guys are with me. Just give a thumbs up in case we can move on to the third question. Is that okay? Shall we move to the third question? So can I give you like 10 seconds for this question? And the answer for this would have been 96. This we've already discussed. We'll move to the third question, the one with the tick, right? We'll move to that question. Let's give you 10 seconds. So we have started already. The 10 seconds. Okay, so cool. That's 10 seconds. I think ample time. Not actually ample time. Honestly, you do require more than 10 seconds to think on questions like this. However, let me be frank with you, right? If you've solved questions like this, you might be able to do. What if you've never solved a question like this? Would you be able to do a different kind of question from these questions? Yes, you will, provided you practice a little bit of these type of questions on the logic that you are getting acquainted with in this session. Right, so I've taken only 5. There can be a little more in terms of fundas on LR, the different types of LR, but this 5 will make you think. The idea is, we cannot do all the LR caselets on earth. What we can, however, do is make you start to make you think differently. And once you start thinking differently, right, the process of doing good in CAT or ZAT, which are more or less the tougher LR caselets, and the IFT, right, you will be able to solve most of the LR caselets. In fact, probably you will take a newspaper and you will be able to solve the Sudoku in probably the next few seconds, and you will not even bother to take minutes. Okay, let's look at this caselet. So the first one was a special series. The second one primarily worked on subtraction and addition, if you would have noticed. This one is slightly different. It works on multiplication. This number 3 multiplied with half gives you 1.5. And you notice 1.5 into half, that means there's an incremental value of half in the multiplicand. That means what we are multiplying with. So 1.5 into half into 1 is 1.5. Again we have 1.5 into 1.5. 1.5 into 1.5 becomes 2.25. We know 15 into 15 or 15 square is 225, but 1.5 square will become 15 square, we understand, is 225, and 1.5 square will certainly be, right, 2.25. There's one decimal here because there's a square, there'll be two decimal shift. We all understand that, right? I'm sure you guys are doing good in quant, right? If you guys are doing good in quant till now, right, please give a thumbs up that you guys are doing good in quant. We'll continue with this question. So you'll easily notice here 2.25 into some number is giving me 4.5. You'll easily notice it is 2. You see the incremental value, half, 1, 1.5, 2. So definitely the next incremental multiplication value should be 2.5. So 4.5 into 2.5, that's an easy calculation, 11.25, right? 11.25. Now some of you may be wondering, how do I say that's an easy calculation? Probably Anil sir's class you would have attended, right? You would have known that, right? Even otherwise, let's look at this in several ways, one or two ways here. 45 into 25. Now we know the middle number here is 35, right? It's one way to do it. This is 35 minus 10, and there's another part that is 35 plus 10. So we all know what is 35 square, 1225, minus 10 square, that is 100. So we'll get 1125. If I put a point here, since there are 2 points, we'll get this, right? That's a pretty simple calculation. The other way is, we all understand 45 into 25, any number multiplied with 25, you simply divide the number with 4 and multiply the answer with 100. That means 45 by 4, which is 11.25, multiply the answer with 100, so it will become 1125. Of course, here it is 4.5 into 11.25. Pretty easy question. You will notice this is on multiplication. So I have taken the next step, that is multiplication or division series. So are we guys good? So we should go to the next question, I think, and I'm sure some of you could have understood this a while back, would have already reached the next question. Okay, before we continue with the next question, let me also tell you this. If you're looking at doing good in LR, now the catch is, you don't start with the LR section. The LR section comes somewhere in between, and it's not towards the end where you say, okay, fine, I'm going to get done with LR, after that I'm going to have a very nice day. So LR is a section you have to be very composed in your mind, because you've done the verbal section previously, and it's very important to be composed, because if you're not done good in LR, which many students had not done last time, they automatically ended up failing even in the quant section, or probably they didn't do quant section to the level that they could have done, considering that quant last year in CAT 2017 was easy. And let me rewrite that, it was easy, bold, underline, it was easy. But students lost out because LR was before quant. They did not have a structured approach, right, towards LR, so they ended up doing bad in quant. That's not what exactly you should do, right? In fact, all the sections have, you should get used to, and normally I say this, whenever you're practicing also, whenever you're practicing questions, right, you should take a 3-hour timeline to practice. So start with your verbal, practice verbal for an hour, then go to LR, practice that for an hour, and then go to quant and practice that for an hour. Definitely keep a 2 to 3 minutes break here, another 2 to 3 minutes break within this 1 hour, because that's exactly what is CAT. You'll notice 3 hours is CAT, first section is verbal, second section is LR, third section is quant, right? And even the practice should start, guys. Fake it till you make it. It's very simple. Fake it till you make it, right? It's as simple as that. So from now on, you should start thinking you are giving CAT every time, even you are practicing a caselet or doing something. So let's go to the question. Okay, let's go to the question. I gave you enough time to solve it. Some of you, I know, were not listening to what I was saying. Probably were not listening, were in fact so interested or engrossed in the questions, because the questions are taken from good sources, right? Some of them are way higher than CAT, and some of them are probably CAT level. Let's look at this question. So what's the answer, right? How many of you are able to notice that all these numbers are square? So you'll have 64, which is like 8 square. We have 4, which is like 2 square. 16, we have like 4 square. 25, which is like 5 square. And 9, which is like 3 square. And 81, which is like 9 square. So it's an obvious guess that the answer is going to be some number square, some n square, right? That's the answer. That's definitely going to be the answer, right? But then what? What's the answer? If I'm talking of the answer, right? How are we going to get the answer, right? We have a 64, 4, 16, 25, 9, 81. If we looked at square, this was 8, this was 2, this was 4, 5, 3, and 9. But can we establish some relationship between 8, 2, 4, 5, 3, 9? Take another minute. Probably you guys have taken a minute probably here. Let's take a few seconds more and see if we can find some relationship here. And you'll notice I'm not sure. Okay, fine. Never mind. Let's do this question as it should have been done. If you notice this, if you take the difference, and what is the difference here? 6 and 4, the two digits, the difference is 2, while 2 square is 4. You'll notice the answer here is 4. 0, 4, that is 2 square. Now, if you take the difference of 0 and 4, which is 4, whilst 4 square is 16, we have written the answer here. 1 and 6, the difference is 5. 5 square is 25. By now, you know the difference is what is going to create the next number. 25, the difference is 3. 2 and 5, difference is 3. 3 square is 9. And you have 0 and 9, the difference is 9. 9 square is 81. 8 and 1, difference is 7. 7 square is 49. Now, some of you may ask me, hey, what? You know what, here we had 6 and 4, the difference is 2, but here we had 0 and 4, the difference is minus 4. Now question, does it matter? Minus 4 square or 4 square, aren't they the same? That is 16. So it really does not matter, okay? It's a square number. So, you know, we all understand, and you guys would have done a little bit of algebra, right? In algebra, we all know what is a real valued function. Right, so when you're talking of real valued function, you know, in CAT, we are only talking of real valued function. We are not even interested in complex functions and Bessel functions and gamma functions and so on and so forth. So it's pretty simple from here. So answer, that's pretty simple. So if we were to track another step, right, this difference would have been 5 and 5 square would have been 25. So you'll notice again we'll have 25, 9, 81, 25, 9, 81, 49, 25, 9, 81, 49, and that will go on. It will continue as a cyclic series here. Right? And like I said at the start, every term should be part of the series. Only then it's a series question. Now, okay, are we good? Right? All of you? I hope you guys are not feeling, you know, tired already. This is just a start. And we have like a couple of questions. This one is a very nice question, right? But before that, we'll take this question. This is not taken from CAT, of course. This is taken from something called Mensa. Mensa are the guys who test IQ. They also test your personality, like your May-Briggs test, right? These are the guys who test your IQ. I've taken it from their website, and normally it said that anyone with an IQ of, you know, 120 plus would be able to solve this question. I'm not saying if you're not able to solve this question, your IQ is not there, because IQ can be built. Let's understand that you can definitely build your IQ by doing a little amount of practice. So let's look at this question. Do we have the 5 or 10 seconds for you to do this question, right? We have 9, we have 2, then we have the 54, we have the 91, we have the 21, we have 16, while we have 92 as well, right? So come to think of it, beautiful series. Honestly, I mean, in all the questions that I've taken today, I think this is my favorite. That's a question number 5, 1, 2, 3, 4, 5. The 5th series question is definitely my favorite, right? So, okay, your 10 seconds. So let's start. We're already at 4th second. So 4. Oh, that looks like some kind of a sign also, right? But never mind. Let's do the question. We're not focusing on the Da Vinci Code today. We're focusing on doing the question, right? So you notice the examiner, when they gave this question, a very tricky examiner's mind, right? And examiners are like this, right? They're the average you and me who are just thinking of taking a question, right, which is simple, but to make it complicated, they just try to twist and turn things. And you'll notice if I just change the position of the comma, right? I change the position of the comma, you see magic starts happening. right? Because this number becomes 3 square, this number becomes 5 square, this number becomes 7 square, then next number becomes 11 square, the next number becomes 13 square, and we all understand the numbers 3, 5, 7, 11, 13 are all prime numbers. That means the next number in question should be 17, and 17 square, that is 289. So here we should have a 289. That means now we can take back the bracket and put back the bracket in its original position. Let's remove the not the bracket, and okay, we got to put back the position of the commas, right? The original position of the comma, like the examiner has written. So let's place the comma back in their positions. So these are the position of the comma. So we have 92. Let me also remove that number here. That is 2 was part of 92. So, and we have the number, and final answer is 89. That's all you had to do is restructure. You just had to look at how we could see the question in a different format just by changing the commas. And trust me, CAT is so much about this. On this concept, I have about 5 questions, and we are talking of caselet. Just by pushing the order of numbers, there are questions that have come in CAT. And you will see in the LRDI sheets, that means the 4th sheet or the 5th sheet, you'll notice there are questions that I'm taking on this logic. And that's the beauty of LR. Something like a series can give you an analysis on thinking how to do better in some other topic, right? Which most people ignore. They think CAT is not about series. Yes, it's not about series, but series can also be used for a question. Let's take the last question on this sheet. I will give you a full 20 seconds on this. This is a bonus 10 seconds because I feel you guys really deserve this, right? I think you guys really deserve okay, what do you say? A 20 seconds on this. So we are already at 5th second. Let me count every 5 seconds. Okay, so that's good. We have 20 seconds are done. I'm sure all of you would have got the answer. If you have not got the answer, let me give you the answer and you tell me how the answer came. I'm giving you the answer right now. The answer is 6. Now I'll give you another 20 seconds. I want you to think on how the answer has become 6. And for a change, no examiner will give you this. They will not give you the answer and ask you to find the logic. But I'm giving you the answer and asking you to find out the logic. Let's do that. For a change, let's do something different in a class, right? So what do you think? What do you think the answer is? Anybody? Anybody would like to post? How do you think this logic of 6 came here? Right? I'm giving you the right away. I'm giving you the answer. Right? It's a very generous day. Right? Okay. It's a Monday. It's the start of the week, so it's very generous. So you please tell me what's the method. So we are probably at 10 seconds. We have another 10 seconds to go. Anyone can post. What is the logic behind the answer? Okay, so I'm seeing a lot of people are thinking. Probably that's the reason I'm not getting any answers on this. Fine, never mind. Let me give you. And you know what? The best part of logical reasoning is most of the logic is very simple, right? We complicate things. We are the persons who think it is too complicated. It may be complicated in case we are not prepared, in case we don't know the right method or the right direction to prepare. But in case we are prepared, it's all really simple. Logical reasoning is simple. Not only logical reasoning, anything that you and I do in life is going to be simple as long as we are prepared for it. If we are not prepared for it, we'll have all the issues and all the concerns and all the problems, right? So let's look at this question. Let me make it big so that I can show you the fun behind this question. And most of the people do not like the answer when I do not like the method when I reveal the method to them, right? They say, oh no, that's really not fair. It's too simple a question to be to have this answer like 6. So you'll notice what I'm trying to do. Okay, look at the first thing, and we are talking of an IQ, guys. We are talking of an IQ of 120 plus on a Mensa. We are talking of an IQ of 120 plus on a Mensa. People who solve it, right? So look at this first thing. The answer is 2, by the by. You'll notice the number of circles here. There is 1 and 1 and nothing else. And look at the number of circles here. 1, 1, 1. There are 3 circles. So that's why 3. There are 2 circles. And it's very simple. I know you guys might be laughing or you guys might be cursing me. How on earth is this an LR question? Yes, of course, it's an LR question. Try cracking it. 120 plus students are able to crack. In fact, I asked it to my cousin, my cousin who is very young and he's like in the 2nd grade, and he was able to do it. You know what he did? He just counted the circles and he told me the answer, and he even gave me the method. Right? And the point is, we have made our minds plastic, and you got to get this plasticity out of your mind and make it as elastic. You got to be like water. You need to flow, and that's exactly what CAT is about. So the answer for this question: 1 circle, 2 circle, 3 circle, 4, 5, and 6. Right? By now you would be cursing me, I know, but yes, that's a question, and trust me on this. Right? If you think that is easy, right? And if you got it right, if you got the logic right, congratulations. If you've not got the logic right, congratulations, because you're in the right place, right? Because we are going to take you to a place where you will start getting logic to questions like this, and you're going to get the logic very quick to questions like this. Because in CAT, the aim, what I normally aim is, a student normally ends up solving 6 case slits. That means 24 questions plus in the given 60 minutes. And it's not a myth. I have my students who have done it, right? We have enough proof that it is possible, provided you change the way you start thinking. Is it too late? No, we have 60 days to CAT, right? And you're talking of something like, that's a huge number here. You're not even estimating. You have 1,400 and, I don't know what number of, hours, right? Okay, so that's the kind of hours that you have. Utilize it, guys. You can sleep after exams, right? You can party after exams. I too will join you, right? But let's go to some more LR. Let's go to case slit based LR. Case slit based LR, right? So this is just a preview. This is just a preview, but trust me, the logic is good. I think we guys have done a little bit of logic on the 6 questions. So please give a thumbs up or a okay in case you feel the logic is good. So we can move to the next question, right? Is that fine? Let's take a brilliant question on something which is trying to give a constraint on a question but has ample amount of logic. And trust me, when I'm doing this question, right, I give a lot of answers. Some people just know the answer, but they don't know the logic behind the answer, right? So we will talk about this. Let's look at the case slit. Superb case slit. Let me read it out for you. I'm sure you guys are with me, so please concentrate on the screen that you have right in front of you. The question says that Parikrama band, you guys would have heard of this band for sure. Parikrama band members are late for a concert in the evening. On their way, they come across a cracked bridge. So there's a bridge, okay? This is some sort of a bridge. This bridge is cracked for sure. That's what they've mentioned. This is sort of a bridge. I know my drawing is bad, but assuming this is a bridge and there's cracks. So I don't know. There's a crack here, there's a crack here or something, right? And there's no light on the bridge, right? The bridge is strong enough to hold at most 2 of them, and they have only 1 torch, right? And it's dark, so obviously it's evening, it's dark, right? Bridge is cracked. They don't want to follow from the bridge. Probably there are crocodiles at the bottom. Probably there is, something else at the bottom, but they don't want to fall down. And they have only 1 torch. So what they do is, there are these 4 guys: Andy, Sandy, Mandy, and Candy. There are these 4 guys. So Andy takes 2 minutes to cross the bridge alone. Sandy takes 3 minutes. Candy would take 6 minutes, while Mandy would take 9 minutes. These are the 4 guys. 4 guys who have to cross the bridge, right? 2 band members together can move only as fast as a slow. What it means is, if Andy and Sandy move together, Andy takes 2, Sandy takes 3, but the time taken when they move together would be 3 minutes, because it's the slower of the 2 of them, right? While if Andy moves with Mandy, Andy takes 2 minutes, Mandy takes 9 minutes. The time taken together will be the larger of the 2, that is 9 minutes. Are we doing good till now, right? So that's the thing. And 2 members should cross at a time. 1 band member should come back with the torch. Otherwise, the other members will be stuck on the other side. All 4 of them should cross the bridge. What is the minimum time taken? So let's do one thing. Let's give you a minute's time by when I will draw another bridge, right? Let it look good. Right? Let me give about 30 seconds, not a minute, 30 seconds. What is the minimum time to cross the bridge? This question will also have a follow-up question. We'll check on that, right? Right? Are you guys on page? Okay, I was just kidding. Okay, so there's nothing like that. Yeah, so all these LR type questions, these puzzle type of LR, right? These puzzle type of LR have a main idea behind it. I'm sure all of you are doing reading comprehension. When you're doing reading comprehension, you primarily understand main idea, right? And once you get the main idea, at least out of the given 3 or 4 questions, 2 questions will directly be related in RC on the main idea. And pretty much the same concept we're going to apply here. And every puzzle, trust me on this, you take any puzzle on earth, it does not matter which puzzle, every puzzle on earth will have right? Are you guys with me? So I was talking of puzzle. Every puzzle on earth, right? Every puzzle on earth will have some main idea. I'm not talking of all LR caselet, but every puzzle on earth. Okay, yeah, are you guys able to hear me? Please tell yes. Yeah, cool, superb, that's very nice. Yeah, what I was talking of, every puzzle, whichever puzzle you take will have a main idea. And trust me on this main idea is what, if you work, if you know the main idea, if you get to know the main idea, a puzzle based question should not take you more than 2 to 4 minutes in actual CAT. In actual CAT, we are talking of only 2 to 4 minutes. In fact, most students skip puzzle based question or they feel it's way too difficult. Right? But the point is not getting the main idea, right? Last time, was there a puzzle based question? Of course, there was a question on chessboard. I hope you remember CAT 2017 slot 2. There's a question on chessboard. That is a puzzle based question. There's always a main idea in a puzzle based question, and try to get the main idea. Here, has anyone thought of the main idea? If you guys could type what is the main idea behind this question, what should we look at when we are trying to minimize the time? Of course, the question says minimize the time. I'm not talking of the question. I'm talking of what is the main idea to help solve the question. For us to ensure that we may be close to the answer or we end up getting the answer, we should end up getting an answer, right? So what is the method that we are talking about? Is there a method? Is there a fine line we got to draw to understand what's the process, right, to work with questions like this? Questions like this puzzle based questions, right? Very puzzling, right? Most people will do a trial and error. Normally we would not work on a trial and error in puzzles, henceforth at least, right? Henceforth we try to avoid a trial and error one, right? So what is the main theme here, or the main concern, or the main idea here, right? There are these 4 guys, right? Andy takes 2 minutes, Sandy takes 3 minutes, right? There is Candy who takes 6 minutes, and Mandy who takes 9 minutes, right? There are these 4 guys. There are the times I've mentioned. Andy takes 2, Andy takes 2, Candy takes 2, Candy, okay, that's Sandy. Sandy takes 3, Candy takes 6, and Mandy takes 9. Now, let's see what happens. What is that we need to think? Most of us would have taken Andy and Mandy together. Andy plus Mandy. Why? So that we could send Mandy with the least time and get back Andy. Okay, Andy plus Mandy, send back. Let's try that also. Let's give it a shot. We'll send Andy plus Mandy together. We'll send Andy plus Mandy. The time taken is 9 minutes. And we'll send back Andy. Let Andy come back. That will take another 2 minutes. Then we'll send Andy plus Candy. That will take 6 minutes. Again, we'll send back Andy. That will take another 2 minutes. And finally, we'll send Andy and Sandy. That's going to be 3 minutes. And you notice the time, okay? 9 plus 6, that is 15. Plus 3, that is 18. Plus 2, that happens to be 22. A decent answer. 22 is there in our answer. But is that the right answer? I'm not sure. May be true, may not be true. Okay, we are not certain about it. Yeah, but to be certain about it, I want to understand, is there a process by which we can think of reducing this answer? We want to reduce the value. We want to minimize. So what is the main idea? That is what we are trying to say. The main idea is, if you want to reduce the time, you would want to send Candy and Mandy, if you can send Candy and Mandy together at some stage, what will happen is we might end up saving time. If you send them Candy plus Mandy together, it will take 9 minutes and you will not bother about sending them again or sending them individually. Individually, if you send Candy with somebody, it would have taken 6 minutes. Mandy with somebody, it would have taken 9 minutes. But now, together we send them in 9 minutes. But the question, can we send them at the beginning? No. That is a little bit of thought process. You cannot send them at the beginning. So when do we send them? Let's try to understand the question. Right? So of course, at the beginning, let's send Andy plus Sandy. That will take us 3 minutes. We'll push back Andy. Andy's come back. Andy's taken 2 minutes. Now, why not send Candy plus Mandy? They will take 9 minutes, right? And now, send back Sandy, because we don't have to send Candy or Mandy back. These guys take a lot of time. We will send back Sandy. That will be another 3 minutes. And finally, we have Andy and Sandy here. Let's send back Andy and Sandy. That would add another 3 minutes. Now, if you count the time, that is 3 plus 9 plus 3, right? That makes it 15. Plus 2 plus 3, that makes it 20. We've got an answer which is the lowest here plus. Right? When cat makers would have made a question like this, they will give the lowest answer and then they will start giving other answer options. In this case, luckily for us, lowest was also the answer. I'm sure many of you would have done that in your exam. What is the minimum time? So you would end up writing the minimum value. May be true, may not be true, but that's a good way of thinking, but may not always be the right way of thinking. But still, right? That's a brilliant method to work, but the better method is actually knowing the problem, right? So we saw that you can get 20. In fact, it was lesser than 22. The good part, it was lesser than 22, and that's the best answer we have here. So that means there's no method better than 20. Okay, but we've got an answer. We have sent Andy plus Sandy. We have taken 3 minutes, and we have sent back Andy. Why not send back Sandy? If I send back Sandy, it will be 3 minutes. And now send Candy plus Mandy. There would be a 9 minutes. And instead of last time we had sent Sandy, now let's send back Andy. We'll take another 2 minutes. And now if we send Andy and Sandy in the end, we'll take another 3 minutes. And you'll notice that the total time there is 15 plus 3 plus 2, which is still 20 minutes. That means in this question, there are two ways to solve it. And both the methods would give us the same answer, and trust me on this, if there is a puzzle and it's easy, right, the only thing you need to worry in CAT is, can you have multiple cases? And that's something most people fail to understand. The moment they get this answer, they're so happy, they're elated, they're excited, that they say, hey, listen, let's stop with this question, because there's another part of the question, who are the last two persons to move across the bridge? And there's a third part of the question, how many ways are there such that all can cross the bridge in minimum time? So probably the next part would be easy, but the next part people would have skipped, right? Because they're not thinking. Now here, the thinking tells us this is one method, there's another method, there's no other method to make it less than or equal to 20, and we have two methods. So let's quickly answer the second part. You would have noticed that the second question is, who are the last two persons to move across the bridge? The last two persons here would be Andy and Sandy in either case. Right? You notice here just changes only here, changes the second and the fourth step, right? Rest all the same. Andy Sandy, Andy Sandy, Candy Mandy, Candy Mandy, Andy Sandy, Andy Sandy. But who are the last two persons to cross the bridge? That's the question they asked. That would be Andy and Sandy. That's your answer. Andy and Sandy are the last two persons to cross the bridge. And we have the last question in this particular caselet. How many ways are there such that all can cross the bridge in minimum time? There are two possible ways. We can put Andy Sandy and then push back Sandy, put Candy Mandy, right? Put back Andy and then you send Andy Sandy. Otherwise, you take Andy Sandy, push back Andy, Candy Mandy, push back Sandy, and Andy Sandy in there. Both will fetch the same minimum time. Are we guys doing good in this question? So you see this caselet. This caselet is trying to tell you how you start thinking on a puzzle-based question, right? Puzzle-based question. And when you're talking about puzzle-based, please think of the main idea behind the question. The main idea, guys, please, is not to minimize the time. That's a question, right? What we are talking about, the main idea is what you have to think. Like here we thought that why not send Candy and Mandy together, and that would minimize the time. I'm not saying it will, I'm saying it might. right? It might, and that might can create a difference in the exam, because if you say it will not, right, I would have got an answer which is larger, right? So that's a nice question. In fact, that's the reason I started with this question as a caselet here. Only 3 questions. We could have made it another question or so, right? So that's a nice question. Are you guys okay, or are you guys really tired or something? Right? Can we move to another question? Right? Give a thumbs up or give a yes, right? To just let me know that you are with me, right? And if you like the question, please give a like or something, right? Share a like. Let's start with the next question. If you say, shall we move to the next question? Right? So that's good. We'll go to the next question. Fine. Are we all with me? Are you guys able to hear me? Are you folks with me? Right? I hope you guys are with me. Are you folks with me? Right? Right? Are you folks with me? All of you? Yeah. So good. Right? Good. Good. Let's go to another caselet. If you guys are superb, that's very encouraging. All of you are on the same page, right? So let's go to another question, right? And trust me, if I'm talking of this sheet, probably apart from the question that was this question, apart from the first, if you talk of the the basic questions that I started with, right? Apart from that question, this question, that is the 92, 54, 91, 21, 16, right? Apart from that question, I think we are talking of the next good question, or probably the best question that I have to talk about today is the next caselet that we are going to do. Apart from the initial 92, 54 wala question, the best case question is just going to come now, right? Trust me on this. That's going to be the question. Let's look up the question. So this is the question. I'll give you about a minute's time here. I totally understand. There is at least a minute. In CAT, normally you take about 4 to 5 minutes to solve it, right? And that's traditionally what is the time anyone would require to solve it, me included, if I were to do the exam. But that's in an ample time to also solve it, right? Okay, so let's take that minute's time. I'm not giving you more than a minute, because there is a lull in on the airwave, and when there is a lull in the airwave, it sounds like it's a cyclone, right? So let's not make that coming. Let's try to solve this question. Let's take about 60 seconds time, right? 60 seconds. Let's take about 60 seconds. Okay, so I think about 30 seconds is done, right? I know 60 seconds is not enough, but still, you understand, your time is precious, my time is precious, right? There can be several other students we can mentor, so we'll keep it as about 60 seconds, another 10 seconds for us, right? Another 10 seconds for us. And you know what? That's the advantage of learning on the internet. On the internet, unlike a classroom, right, where I'll have to wait for every other student, here I can directly start with a question. That's a beauty. That's the beauty of the internet. Internet gives us this leverage of understanding because everyone is glued on. I'm not asking you an answer directly. Probably few of you might give an answer. That's the beauty of the internet. We can start questions immediately. In a classroom, normally I also take classroom, right? And whenever I've taken classroom in the past, I would have to wait for the students. I would have to wait for the students to take it, right? But while in the internet, everything is recorded, so you can play it again and again, and that's the beauty of internet. I hope you guys are understanding, the advantages that the internet. They say, right, the leveler of the world that is flattened today is because of something that's called the internet, right? That's the internet. In fact, they should not have called it internet. They should have called it something like something better than that. There could have been a beautiful word for it. Okay, let's read the question and let's start with the question. Certainly, the question is talking of an 8-liter jug. which is filled with milk. That means this jug is filled with milk. There are two empty 5 liter and 3 liter jug available. This is the 5 liter and a 3 liter jug available. Two empty jugs, one is 5 liter, one is 3 liter. We got to divide the 8 liter which is here. We had the 8 liter which is here. We got to divide this 8 liter milk into two equal parts, right? By using the 3 jugs. There are only these 3 jugs. 1, 2, 3. There are only the 3 jugs. We got to divide it into two equal parts. By two equal parts, what do we mean, right? I am guessing we all have understood two equal parts means 4 liter and 4 liter. The beautiful part is they say no other measuring device is available. There is no gradation mark in these jugs and eye estimation is not acceptable. So you cannot be like the milk vendor who says, Hisar, it looks like 4 liter, right? You cannot say that in this question. It's almost 4 liter, approximate 4 liter. That's not allowed in this question, right? So let's keep that very clear. The question is clearly about the 8 liter jug, right? The 8 liter jug, the 5 liter jug, and the 8 liter jug, the 5 liter jug, and the 3 liter jug. We got to divide it into 4 liter. Like this is a puzzle. Like I'm saying the previous question was a puzzle. This question too is a puzzle. This question too is a puzzle. So which means that there will be a main idea behind it, right? Any puzzle based question will be having a main idea exactly like your reading comprehension. What is the main idea? What is the purpose, right? What if we do? We'll end up getting the answer to this question. We'll simply end up getting the answer. What if we figure out, right? What is it we got to figure out? Reading it, right? You want to get 4 liter. The thought process that should come. I'm sure some of you are with me, right? I'm sure all of you have understood, the sense of urgency to get the thought process here. And once that comes, immediately you're done with the question. What is the thought process? Some of you might have thought, and you've thought rightly, that why not end up getting something like a 1 liter? The moment you get a 1 liter in any container, it would be easy to take 1 plus 3, that would give us 4, and we have an answer, right? So the question was simply relying on the idea ki can we somehow get a 1 liter? That's it, right? Can we somehow get a 1 liter? And thereafter we will talk about the minimum number of pouring and etc. etc. That's part of the question. Let's try to do that 1 liter part, okay? So let's say first this container had 8 liter, this container had 0, and this container had 0. So each step we'll take one by one the step. So one pouring is one step. That's what I will try to say. So let me fill this container. That's 3 liter container. So from 8 I can only pour 3. I cannot pour half and say 1.5 or something. We can only pour 3 because we know we can measure 3 here. We can measure 5 here. We can measure 8 in the first container. So this container is now having 5 liters. This container, the 5 liter container is 0 and the 3 liter container has 3. That's your step 1. Step 2, let's transfer the 3 liter from the 3 liter container to the 5 liter container. That means here, right? We transfer it here, right? So once we transfer it, you'll notice, this becomes 3, this will become 0, this is unaffected because it's 5. 5 means it remains 5, right? So we transfer it and let's see. Okay, so step by step we'll want to do. Our aim is to get the 1 liter. Okay, so let's make this, that is 5, 3, 0. Again, let's play the game again. That means we'll try to push the 5 liter into the 3 liter container. That means from the 8 liters we have 5 liter. We'll try to put from the 5 liter 3 liters here. That would be 3, 3 and 2. Guys, am I going fast or is the pace fine, right? Or do you want me to increase the pace? Just let me know, right? You give feedback. We'll keep it consistent here, so that I'm in sync. See how whether you guys are in sync, right? Okay. Now notice the reason why I did this 3 again here. In case we transfer, then what will happen is 3 liter, if I push it, 3 liter, okay, the 3 liter, if we push it to the 5 liter container, this would become 5, but we are left with 1 liter here. Correct? Beautiful, we've got the 1 liter here. Right? We have got the 1 liter here. Fine. Okay, we have got the 1 liter. This is what we wanted. We wanted the 1 liter, right? We've got the 1 liter. Superb, the 1 liter is arrived. Now what? The worry. Can I pour 3 more liters here and finish 3 plus 1, that is 4? Nah. You got to transfer this 1 liter to some other container. Only once you transfer the 1 liter to some other container will you be able to get a 1 plus 3. So let's transfer it. To transfer it, I need an empty container. So let's take this 5 liter, put it here. We'll get 7, right? Here this will become 0. That will remain 1. So we have a 701, right? We have a 701. Now we can transfer this 1 liter here. So that is 1, 7 and 0. Now it's very simple. You can understand from 7 you pour here something. That will give us 3 liter. So 3, you pour it to the 3 liter container. That will be filled with 3. That will be 1 and that will be 4. And the final step, of course, you transfer back 3 liters from here to the second container. That is the 5 liter container. We have a 440. Have we got an answer? And how many steps? That is step 1, step 2, step 3, step 4, step 5, step 6, step 7 and step 8. So 8 steps we've got an answer. Beautiful, we've got an answer, but my question still arises, right? Is it the minimum? May not be. But we've got a method to work, and the method is working on the 1 liter. That is the first idea, or also called the main idea that you work in reading comprehensions as well. But there could be supporting ideas, right? What could have been the supporting idea? What if I do not have the 1 liter available here, and I have the 1 liter right here or somewhere else? That means if the 1 liter is not in the 3 liter container in the beginning, can I reduce the number of steps is my aim. So instead of 8, we've got an answer 8 now, definitely less than 9. But can we reduce it to 7 or 6 or 5? That's our aim, right? We want to reduce it to some number like 7 or 6 or 5. Let's see if we can do that. If we can do that, we are pretty good with this question. So let's try to reduce it, right? So my aim is to fill the 1 liter in some other container. So I will give you an algorithm here, and this algorithm works beautifully, and I'll keep it. I know it's a little messy. There's a lot of data on the sheet, but I'll give you an algorithm which will work, right? The algorithm goes like this. Whatever is the most empty container, example 5 liter, if it is the most empty container, fill it from the 8 liter container. If the 3 liter container is the most empty container, fill it from the 5 liter container. But what if the 8 liter container becomes the most empty? Fill it from the 3 liter container. Are we okay with the algorithm? Right? Okay, pretty simple algorithm. Super. So let's start. The most empty container, of course, is which one? The 5 liter. Let's fill that first. So 5, this remaining is 3 because from 8 you've transferred 5 and this will become 0. Now, which is the most empty container? The 3 liter container is most empty. There's nothing in it. So we fill that from the 5 liter container. That gets us 3. There is 2 in the 5 liter container and 3 in the 8 liter container. Now, which is the most empty container? Now, many of you might say the 5 liter container is most empty because there is 2 out of 5 liter. Some of you may say the 3 liter container is most empty because there is 3 liter out of 8 liter. All of you have done percentages. So you understand this is 40% while this is 37.5%. So which is more empty? 37.5 or 40%? Obviously 37.5% is more empty. That means you got to fill the most empty container, which is 8 liter. From which container? From the 3 liter container. Right? Okay. Fair enough. So let's do that. Let's do that. Okay. Let's quickly change 3 to here. So we'll get a 6. We have a 2 and we have a 0. You guys understood? The most empty was the 8 liter. It was not the 5 liter, and 3 liter was filled. So there is no question of the 3 liter, right? So let's do one thing. Now, which is the most empty container? It's but obvious the 3 liter is fully empty. It is 0% full. So we'll fill that from the 5 liter container. You see the arrow marks? You see the arrow marks are representing what we'll do. So we'll change that. We'll make it 2, 0, and we'll maintain this is 6. The best thing is now the most empty container is the 5 liter container. If you fill the 5 liter container, you have a 5, you have a 1, and you remain with a 2 in the 3 liter container. And you notice the magic number that we always wanted is here. And we know the moment you get 1 and not in the 3-liter container, it should probably be a step or two by which you should get the answer. You already have a 1, fill a 3 liters, fill this container to make it 3 liters from here. So you don't have to follow the algorithm beyond this step. Stop algorithm, right? Stop algorithm. So what is the algorithm? Whatever is the most empty container, fill it with the previous container. 5 liter was the most empty here, so we filled it from the 8. Next here, 3 liter was the most empty, we filled it from the 5 liter container. Here, most empty was the 8 liter container because 3 out of 8 was there and 2 out of 5 was there. So 3 out of 8, we filled it from the 3 liter container. So we had 6 to 0, most empty container was this, we filled it from the previous, and so on. But here is where you stop the algorithm because you already got what you wanted. Your intent was there, right? If you got the main idea and the supporting idea, you don't have to worry about a fact and a reading comprehension. You are done. We are cool with the question. So let's now fit the rest of the things. So we transfer from here to here, 3 liter, and we have a 4 liter. We have a 1 liter. The final step, as you already know, 3 plus 1 will give us 4. 4 and 0. You count the number of steps here. This is a 0th step. Okay, that's the initial position. Right, that's not the first one. There's the first step, second step, third step, fourth step, fifth step, sixth step, and seventh step. You notice we reduce the number of steps. Instead of 8, it will become 7, and that is the least number of steps. And beautiful, this algorithm can work. In fact, I would like to tell you. You got to think beyond this question. Today we have taken 3 containers. Why not try it for 4 containers? And that's exactly what CAT is about. When you start thinking beyond the exact problem, when you start thinking, what you can do with the problem, how the examiner may test you on a problem like this. See, there are some set of puzzles in this world and some sets of LR types in this world. And anyone who makes a new LR will be influenced by these types. All you have to do is start extrapolating, start thinking what new can be formed out of something simple as this, and you have got an answer, right? So let's answer the question. By the by, that's exactly what we wanted to do. What's the question number 4? What is the minimum possible number of pourings needed to achieve this result? That means the result of getting a 4 and 4. So the minimum happens to be 7, right? Okay, are we good with this? Superb. Let's go to the next one. The next one is here. What is the quantity of milk in liters in the 5-liter jug after 3 pourings? Now, after 3 pourings in the 5-liter jug, where is the 5-liter jug? 5-liter jug after 3 pourings. Pouring 1, pouring 2, pouring 3. How much is it? 2. But the 5-liter jug after 3 pouring here is 3. Do we know whether they are asking minimum number of pourings or not minimum number of pourings in this question? The word minimum is not given. In fact, I can do this question, forget 7 and 8. I can do this question with 50,000 pourings also. Probably with 3 lakh pourings as well. So we have no clarity on this answer. Answer would simply become cannot be determined. However, if they had mentioned minimum word, they had mentioned the word minimum, then your answer would have simply been this. The answer would have been 2. If the word minimum was there, right? The word minimum, no word minimum, no minimum word. If that was there, then the answer was 2. But that is not there. So the answer is cannot be determined. Are we guys doing good? Yeah? Superb. So let's look at the question number 6. Again, very simple, cannot be determined because the word minimum not there. Minimum not there. So it's simple. That would have been the easiest question. Suppose, the best thing about cannot be determined. A lot of students have told me their answer is cannot be determined. I asked them why is the answer cannot be determined. You know what they say? They say I don't know to find the answer, so it's cannot be determined. Guys, the question is cannot be determined. Not if you cannot find the answer. The question is cannot be determined if anyone who is prepared for the exam cannot find the answer. Okay, that is a difference. It's not about you being determined or not. But yeah, that was a very innocent way some student had once told me. I cannot find the answer, so the answer will be cannot be determined. That's nice, but let's push that to the interview stage and not now. Right now you have to find the answer. Right? Let's look at the question 7. How many times a 3-liter jug gets filled completely during the process? How many times does a 3-liter jug get completely filled during the process with minimum possible number of pouring? Check it. how many times the 3-liter jug gets filled completely. That's exactly what we want to do. And let's see, right? How many times the 3-liter jug gets filled. But they've used the word minimum, right? They've used the word minimum possible pourings, right? So let's go to the first page where we had solved the question. The 3-liter jug gets filled. You notice the 3-liter jug got filled here once. The 3-liter jug got filled here once. That's it. Rest was 0, 0, 2, 2 and 0. That means the 3-liter jug, right? You'll notice here 3-liter jug got filled exactly twice. The 3-liter jug got filled exactly twice. Okay, so that means that's your answer. How many times does the 3-liter jug get filled during the process of minimum possible number of pourings? The answer is twice. The answer is twice. 2 times we had this case, so twice it is available for us, right? Are we good? Good question. I hope you guys are all doing good. That's a nice way to map a nice puzzle based question, right? If you are still with me, right, let's take another question. Let's take another question. All beautiful questions that I have sorted for you, right? I'm going a little slow today. You have noticed I'm going a little slow today. The reason that I'm going a little slower than what you might anticipate me to go is simply because, you know, I feel that, you know, once you get used to my pace and the way I deliver stuff, right? What will happen is we can always increase the pace. We can always increase, and by the time we reach a few standard number of classes, you'll notice that you will want to be faster. You'll want me to be faster in those classes. As of now, also some of you may be much faster than others. That's really good sign. But come to think, another few classes with me, maybe another 3-4 classes, even your thinking will improvise, right? And probably, for all you know, you'll become better than the way I am thinking. You guys are young. You guys are young. You guys are dynamic in thinking, right? And that's exactly why the IAMS need you. Yeah, I think I need a thank you for that. I just complimented you on you being good, right? So let's just see. Are you guys able to hear me, right? Are you all with me, right? Are you guys able to hear me, guys? Yeah, are you all with me? Yeah, we'll go to the next question. Superb. So just give a thumbs up or a tick or something if we can move to the next question. This question is slightly different, but that's a different way to approach a question, and I think this is one really weird type of question. It involves a truth and lie kind of thing, binary logic that we call, right? That has some element of English as well, right? It has some element of English, so that's the reason I've introduced it. But yeah, truth and lie, binary logic, and English-based reasoning (LR) questions are pretty common in CAT. In fact, if you check CAT 2009 to CAT 2013, there is several questions on, you know, logical reasoning which are more on the lines of English and negation and such questions. Now you might wonder, why have I only told about these 5 years having these type of questions? You must understand, for these 5 years, the paper was set by an outsourced vendor, right? Now these vendors are people who make these exams for abroad education, right? For education abroad, they make tests. So, you know, whenever you have logical reasoning for abroad exams, for example, LSAT, for example, GRE, for GMAT, right, and such exams, the LR will have a lot of element of English. That means your verbal. By English, I don't mean literature. By English, I mean, you know, your grammar and your, you know, elements of critical reasoning. So binary logic is pretty much there. Binary logic is part of LR such type of questions, right? So that's exactly what I want to drive in this question. I will give you a minute. I will give you a minute to think on this question. A beautiful caselet, and you know, then we'll solve it. And in the meantime, we'll also have a lot of discussion on this caselet, because it's a nice question to discuss. It's a nice question to discuss. It will also get you thinking on English. So be with me in case you guys are good in English. I think I need an answer from all of you who are doing good in your mocks in English. You guys should give me an answer to some question that I'm going to ask you. In the meantime, not the answer to the question. That means not what was the answer. That is one question. And there's a second part of the question. Which of the following statements will be the natural conclusion drawn out? Okay, there's one layer and all that. So we will just try to figure out that later. But what I want you guys to do is just read the question. So I'll give you about 30 seconds. 30 seconds. Read. And then we'll try solving this out. We'll try solving this out in about 30 seconds. That will be a brief time, I understand. But that's a good enough time to solve it. Good enough time to solve it. Okay? Superb. Okay, I am hoping all of you, right? All of you are also preparing, some diverse things like, vocabulary. Sometimes vocabulary, last 2 years vocabulary is not common cat. I'm sure you guys are also doing that. What in case it just comes? Same way like you're preparing for LR. What if it is tough this time again? But what if it is easy? So keep your eyes and ears open to that as well. Right? Be open to alternatives in exam. LR is exactly about alternatives, finding out cases, finding out alternate cases, and finding out the better of the alternative cases. Right? So that's what we will discuss in the next question as well. Right? So shall we start with this question, guys? Shall we do this? Is that fine? Are we good with this question? Right? So let's look at the question. So we have this question: in a certain club, only two types of people can be admitted. Right? There are absolute liars and absolute honest. A journalist meets some members of this club who answer his question either by a yes or a no. Right? When asked the question, are all of you truthful? They all gave the same answer. So my question is not what is the answer. My question to you is what is the inference, right? Or what is the assumption that you have made while you're coming up with the answer? So this is like a question on statement assumption. You guys would have done that in English, right? Statement assumption, statement conclusion. So what is probably the assumption based on which we have to arrive at this answer? Right? We have to arrive at this answer based on some assumption, right? Otherwise, if that assumption is not arrived at, you're still getting an answer maybe, but you're not really solving it with the critical reasoning method. So I want to push the critical reasoning method in this question. So let's see how you guys approach it. Anyone feels that there is an element of critical reasoning here? Binary logic, trust me on this, there's always an element of critical reasoning, right? Always an element of critical reasoning. So let's see what you guys have thought as of now. Notice, okay, so I see some answers here. Good, very nice. Let's see what is that I am trying to say. The journalists are meeting these people who are absolute liars and absolute honest. Assuming there's a class of all honest people, right? If I ask one person in the class, are all of you truthful? What do you think their answer is going to be? Do you think their answer is going to be yes? Do you think their answer is going to be a no? If a person is honest, what do you think the answer will be? The person should say, don't know. Why don't know? Right? Why don't know? Because the person do not know. The person do not know about the other persons in the particular class or a particular club or a fraternity or the college. They will not know. Let's say there is this person, right? And there is this person, and there is this person, and there is this person. There are these four guys, A, B, C, and D. A is honest, B is honest, C is honest, D is honest, but they do not know whether they are all honest. If I ask the question to A, are all of you truthful? If A is honest, A will say don't know. But you notice what is the answer is given. The answer was always a yes or a no, which means what is the critical reasoning part? What is the assumption that we can make here? The assumption that we can make here is everybody or everyone, right, knew whether the other person was honest or liar, right? So everybody knew whether the other person and themselves, whether they were honest or whether they were liars. Otherwise, we don't come at a yes and a no, right? So that's a good element of critical reasoning in this question. That's a nice question, simple one though, but there's a good amount of assumption here that we'll have to take. Otherwise, we are not done with this question. So now, once we are done with the assumption that everyone knew everybody in the club, so let's do this. Okay, there's a club, member A, member B, member C, member D. That's A, B, C. For the sake of it, we can say the possible composition of the club. All could be honest, all could be liars, and some could be honest and some could be liars. So there are these three possibilities in the club, right? Three possibilities in the club: all honest, all liars, some honest, and some liars. Let's see. Now, assuming ABCD is a club and the journalist comes to this club and all are honest, they know each other, they are honest. So, I am the journalist, let's assume. I ask A, hey, are all of you truthful? So, what do you think A says? A speaks out, yeah, we're all truthful, right? And I ask this question to B, hey, are all of you truthful? And B speaks out, yes, we're all truthful. And then I ask this question to C, and C says, yes, we're all truthful because they're all truthful, right? If all are honest, their answer is yes. Good. Now, is it necessary all have to be honest? No, we have a second case. Let's discuss that, right? Maybe all are liars. Now, see the catch. I'm asking A. A is a liar. A is a liar. Okay, so look at A's eyes. Let me tell you that A is a liar, right? So I ask A, hey, listen, are all of you truthful? And he says, yeah, I'm truthful because we're all truthful, we're all truthful, right? Is A telling the truth? No, of course not. A is a liar, right? He always speaks with that, right? He's a chronic liar. He's an absolute liar. We'll ask B, hey B, are all of you truthful? And what do you think B's answer is? Yes, of course, you're right. B also says yes. In fact, I asked D and D also says yes. And in fact, I asked anybody in the club, right? And they all say yes, but they're all liars, they got to lie. Every time we ask the question, they have to lie, and they lie and they say yes, we are all truthful. They're all liars. Now let's go to the third case. Some are honest. So let's divide the club. See, I have no affinity towards the letter A and letter B. It's not that I'm saying letter A is honest and letter B is dishonest or C is dishonest. For the sake of convenience, I will say, for a minute, so you don't take it to heart if your name starts with a A or a B or a C or a D. I'm just saying for the sake of it, A is honest, B is honest, C is a liar, and D is a liar. This entire thing is a club. This full thing is a club, and they know each other. This is a fraternity and they know each other. A knows that B is a honest guy, C is a liar, and D is a liar. B knows that A is honest, C is liar, D is liar. C knows A and B are honest while D is a liar, and so on, right? Everybody knows everybody. I've just taken 4 as an example. It could be as large a club that you want. So some are honest, some are liars. Let me ask this question to A. What is the question? Are all of you truthful? And you know what A says? What do you think A says? Do you think A will say yes? He's an honest guy. He says, no, I'm honest, but this fellow C, right? And this fellow D, these guys are dishonest. So are all of you honest or are all of you truthful? A says no. So the honest person will say no. Let's try with B. And B will say, hey, listen, are all of you truthful? And B thinks, hey, listen, A is truthful. So should I say we are all truthful? Then, the guilt pang will say, hey, no, we are not all truthful. C and D are liars. So he says no. He does not reveal exactly, but the answer is going to be no, because they only can give 2 type of answer. They could either give a yes or give a no. We don't have a third type of an answer. Right? Let's do one thing. Let's now ask the liars. Let's ask C. Hey, C, are all of you truthful? Now C is a liar. C is a liar. What did C say? Yes, we are all truthful, because C is a liar. So you would want to make a false statement. Yeah, we are all truthful. And if we ask the same thing to D, are all of you truthful? You notice D is a liar, and D would say yes. You see the conflict of interest here? When we have some honest and some liars, we have two types of answers, no and a yes. But they said the answer is a yes or no, but they all gave the same answer, and we have already discussed the critical reasoning element here. The assumption here is that everybody knew everybody else. That's the assumption, right? And they have told they all gave the same answer. That's part of the statement itself, which means we cannot get this as a possibility. We cannot have, no and yes. Conflicting answers should not be there. Everyone should give the same answer. So that simply answers the question. Here all of them gave the same answer. Like here all of them gave the same answer. The answer was definitely yes. Superb, very simple question. And which of the following statements will be the natural conclusion drawn out? There is one liar and all are truthful. That's not true. You notice that all are honest or all are liars, right? Okay. Can we say all are telling the truth? Can we say all are telling the truth? Yes, there is one possibility all are telling the truth, right? There is one possibility which says all are telling the truth. Can we say there is one telling the truth and all are lying? No. But can we say all are lying? Yeah, that's also allowed. All are lying. Pretty much there, pretty much in sync, right? We can definitely say all are lying. But it is like two cases. In one case, all are honest. In one case, all are liars. Because in both the cases, everybody gave the same answer, and the answer was either yes or a single answer. So what's the right answer that we're trying to map here, right? The answer is definitely going to be either 2 or 4. That means either all are telling the truth or all are lying, right? So that's a good hour and a half of session. I hope you guys have learned something. We will definitely work on more number of things, right? I think we will stop with this today, right? I hope we have learned something, at least something. Okay, let me put it as at least something new, right? If that is okay, right? Please give us a thumbs up or tell a yes. I'll be very happy, right? And next time, like I said, right, we will remove the entire idea of you being perturbed, you being in a fix on how to solve it. We will remove the fear from your mind, right? And trust me on this, right? LRDI is something that's going to be easy as long as you work on the methods that I said, and you will have to trust me for the next few days, because what I'm trying to do in these classes, right, build a thought process, and once the thought process is built, no one can stop you. The best thing about being good at LR is that once a person becomes good at LR, he starts solving real life problems in a much better way. So LR is not just about being good in LR. LR actually helps you in life. So thank you very much, right? I hope you guys have learned something new. If the answer is yes, thank you. If the answer is no, let me know how I can improve. I'm sure none of you will tell that, but yes, thank you for all your support, and I will see you guys in the next class. That is a thank you from my side.
You can learn any subject, anywhere, any place, and on the go. Come, let us go the other way in learning. Download our revolutionary app for free, AMC.